but both are null because no previous and backward nodes are there in. If it is not a null pointer, if start is not equal to null, else we have to do, because we are adding a node at the last of the list, then we have to point out that is the last pointer. So set pointer is equal to last, pointer forward, new node, whichever new node, we have to store that address in the pointer forward, and last pointer forward is stored in the last. So information is stored, and forward is because the new node whichever is inserted, it is not pointing to the any other node because it is inserted at the end of the doubly linked list. So last forward pointer is equal to null. So insert a new node, insert new node in sorted doubly linked list. If we have a uh, sorted linked list or in sorted doubly linked list, sorted linked list are these for which the element values are in the successor or decessor values, as in the diagram, that is 10, 20, 30, 40. 10 after that 20 is larger than 30 is larger and 40 is larger. So these type of lists are sorted list. Before going to insert a new element in a sorted list, we have to find out the whichever new element is going to, whichever new node is going to insert, where it lies in the list. As if we want to insert a new node, that is 25 in between, 25 lies after the node, second node where 20th element is stored, and between the third node where 30th element is stored. So in sorted doubly linked list, we have to first find out the where the element is lies, then we can change the pointer variables according to the that. So algorithm to insert a new node in sorted doubly linked list, we have start again. First step is same, that is if there is no node, then we have to we are going to create or insert a first node of the doubly linked list. So it goes to start is equal to null, then set start is equal to last new node, that is same. So its back pointer and forward pointer both contains the null value, and information pointer contains the item which is information going to be stored in it. So in case of step second, if it is not null, if it is not first, so then first of all set pointer is equal to start, we have to start checking the where that item is live. We have start checking from the first node and find out the particular location. So first of all set pointer to the start new node, then start back null, and start information is equal to item whichever the element is going to store. Then start forward is equal to pointer back is set to the field information, that is whichever the information item. If item start information, if item is less than start information, first pointer points to the first node. If whichever the element we are going to insert is less than the information, then we have to perform these operation. That means that can be added before that. So if item, let us say we are going to add 25 with the previous example. First it is stored 10, 25 is less than start information, no, it goes to else part. Then it comes 20, 25 is less than to 20, no, it goes false, it goes to the else part. Next come 30, item is 25 which we are going to insert, so 25 is less than to 30, condition is true, then it compiles these 5 steps, that is it starts the new node, it converts the back null pointer and information to be stored, and forward pointer to be set. Else if item is greater than, if item is not equal to, if item is greater than the last information, last element of the, then pointer is set to last. That means node is going to be insert at the last of the doubly linked list. So else flag is to set to 1. So basically in sorted list we have first find out the where the element lies, where its insertion order is lies. As in this example, the element insertion order is in between or middle of the list. if we are going to insert an element which contains the value that is 50, then it is inserted, new node is inserted at the end of the program. So next topic comes, that is deletion in doubly linked list. Deleting a node requires that we logically remove the node from the list by changing various links and then physically deleting the node from the list. So basically we cannot directly delete the node physically. Firstly we have to delete that node logically, then we have to remove from the memory location where it is stored. So deletion of the first node of two-way linked list we can perform, deletion of the last node of two-way linked list, and deletion of a particular node of a two-way linked list. So deletion in doubly linked list. Deleting a node requires that we logically removes the node from the last, changing various links. Any node in the list can be deleted. Note that if the only node in the list is to be deleted, an empty list will result. In this case, the head pointer will set to be, if there is only one node and we want to delete that node, then the head pointer is to set to be the null. So basically deletion of the first node. Deletion of the first node means that the value data item that is stores the value 20 to be deleted. So the first node will becomes, that is data value that is 10. So head basically points to the node where 20 is stored. If we set the head pointer to the node where 10 is stored, then logically the element first node is deleted where 20th is stored. So what is the algorithm to delete first node? That is, if start is equal to null, then print no node exists, means if there are already no nodes in a doubly linked list, then which node we are going to delete. So basically no nodes means no node exists and return null value, that means there are no nodes, all nodes are already deleted. Else if start is equal to last, if start is equal to last, then if there is only one value, start pointer is equal to last pointer, then temp is equal to start. We can assign the value of the start to the pointer, that is temporary pointer, that is temp, then start last value will be converted to the null. So basically if start is equal to last, then null value is assessed and null value is assigned to the start pointer. So the if one node is there, then that node is deleted. If there is no one node, more than one nodes, means if start is not equal to last, then we will move to the step 3, that is else. Temp is equal to start, start is equal to start link. So first of all, whatever the start pointer's address is stored in a temporary pointer, that is temp, that means temp is now pointing to the first node, and we can change the we have to change the start pointer. Start is equal to start link. Start link indicates that the pointer variable which stores the first node address, we can change that address with the second node of the address with this example, that is start is equal to start link. So whatever the address of the next link, it stores in the start, and start back is equal to null, that is value is null, that means the next node is delete. So delete temp, when we delete temp, it logically removes the first node of the doubly linked list. So deletion of the last node is, it is as easy as deletion of the first node. We need to change the address field at two places. One is last pointer field and the second last node is the forward field. That means, let us say same example, we want to delete a node which stores the data element that is 40. So what 40 data element contains is its forward field contains the address of the node where 10 data element is stored, and the backward field stores the address of the where 10 element is stored, and forward field stores the null value, that is no more nodes in the doubly linked list. So basically what it performs, it moves the but pointer to the temp, which points to the 40, and where the 10th element is stored, its next pointer becomes null. If we set the next pointer to the null value, then it directly removes the, logically removes the node, last node where 40 is stored from the linked list. So what are the steps? That is, if start is equal to null, then print underflow and return. If start there are no node in the list, then which node is going to be deleted? So it returns the underflow, condition is false. Else if start is not equal to null, but if start is equal to last, means there is only one node, then we have to move to the last node address to the variable temp, pointer variable temp, and start variable to the null. That means we have to convert the null value at the last. So if there is one node, that node is deleted now, and doubly linked list has no more nodes. If there are more than one nodes, then we will move to the step 3, that is else part. That else part contains temp is equal to last, whatever the last pointer variable is stored in temp variable, and last pointer value is set to the back pointer of that node. Whatever the back pointer value of that node contains, that assigned to the last pointer, and forward pointer value contains the null. So the last value is delete. So next one, if we want to deletion of a specific node or in between of the node. So for this we need to compare each node with the given information unless we find the specified node or the end of the list. This means we have to traverse the linked list as long as pointer information is not equal to item. So firstly, deletion of a specified node indicate we have to first traverse the whole doubly linked list until the required information or required element to be deleted is not found. As in example 20, 10, 40, there are 3 elements that are stored in this. So if we want to data element where 10 is stored, we want to delete that node. So first we have to find where that node is lies. When that is found, then in this example, suppose we want to remove node second. So what we have to do, where the data 20 is stored, its next pointer should contain the address of the node where data element 40 is stored. So we directly change that address to the address of the 40th third node, and then the in between nodes address is automatically deleted. So what is the algorithm of this? Step 1, if start is equal to null, again if there is no node in the list, that underflow condition will work. Else if start information is equal to item, we have to traverse each node, then find out if start information, if first node contains that information, which node we want to delete, then set the pointer to the start. If start is equal to last, if the start information start is equal to last, then start last and last null, both pointers sets to be null value, then that node is automatically deleted. Else if first element or first node does not contain the required information, then we have to move to the next pointer. So whenever the value is find out, then sets the start forward and start back is equal to null. So whatever the else, last start information, if the last node contains the required information to be deleted, so pointer last is to be set to be the null value. Else pointer start forward repeat while the information is not set to 1. Whenever the information is find out, we have to change its left pointer, right pointer to the back and forth, so that the value to be deleted. So what are the disadvantages of doubly linked list? Each node requires extra space for storing and additional pointer. While manipulating the list, extra care should be taken to manipulate both links. Thanks.